I'm Anil Kumar, sharing with you some applications of vectors, and we are working on velocity at present. The question here is, a boat is at 6 minus 6, cruising at 10 kilometers per hour in the direction minus 3, 4. A fishing boat is at 0, 0. So we are given a scenario. Now the question is, find when the boat is due east of fishing boat. So that is the question for you, part A. And part B is, find the shortest time and the position of the boat when it is nearest to the fishing boat. So these are two questions for you to solve. You can pause the video, answer the question, and then look into my suggestions. Now let's try to understand the scenario here. So I'll kind of sketch something rough here to just see what the question is. So we are given a boat is at 6 minus 6. Let's say this is 6 and this is minus 6. Okay, 6 minus 6. Cruising at 10 kilometers per hour in the direction of minus 3, 4. So minus 3, 4 means that if minus means going left and 4 means going up, right? So 3 is halfway 6, right? And 4 is more than halfway. This was minus 6, kind of here, right? So what you can see here is that the boat is kind of moving in this direction. So let me sketch this, okay? Okay, so let me make it a bold diagram here, kind of like this, okay? So this is the direction in which this boat is going. A fishing boat is at 0, 0. So there is a fishing boat here at 0, 0. Find when the boat is due east of. So at this point, the boat is east of fishing boat. Do you understand? That's what we mean. Second part is, find the shortest time and the position of the boat when it is nearest to the fishing boat. Now this fishing boat is stationary, so it's important to understand. So it's like a point. So the shortest will be perpendicular to it, so at right angles. So that's the whole concept. Now with this in view, I'd like you to pause the video, answer the question, and look into my suggestions, okay? So let's begin by writing the equation for this particular question. When you say the boat is at 6, 6, cruising at 10 kilometers per hour in the direction of this. So generally, so the position x, y will be given as the initial position x0, y0 plus time with the velocity, right? So velocity component for x and velocity component of y. So that is the general form. Now in our case, velocity magnitude of this is given as 10 and the direction is minus 3, 4, right? Minus 3, 4, okay. So minus 3, 4 gives you, let's work on this. So if I'm saying that direction, so let me call this direction as m, okay, let's use a different, okay, this will work. So just substitute. M is the direction here and m is given to us as minus 3, 4, right? So what is the magnitude of this? Magnitude is square root of minus 3 square plus 4 square square root, which you know is 5, correct? 9 plus 16 whole 25 square root is 5. So this gives you a magnitude of 5. We need 10. We don't need 5, 10. So to get 10, I have to multiply this by 2. You get the idea, right? So we have to multiply this by 2. So what we get here is that the component for velocity is 2 times, that is minus 6 and 8. So that is your velocity component. Do you understand now? Since here's a check, right? Now you do square root of minus 6 square plus 8 square. What do you get? 36 plus 64 square root, which is 10. Does it make sense to you, right? So direction, we could have scalar multiple of this direction, maintaining the direction. But that is the velocity vector, correct? And its magnitude is given to you as 10. Do you see that part? So first thing. Now let's get back to the question. Find when the boat is due east of the fishing boat. Well, I skipped two parts of this question. So first two parts were to write the equation first, right? so, so let me write down the equation. So we are saying the position xy will be, initial position is given to us 6 minus 6, right? So this is 6 minus 6 plus time t times velocity vector, which is minus 6, 8. You can see it is parallel to this scalar multiple twice the direction. Is it okay? So it makes sense. So that is your position vector. That is my position vector, okay? Fine. Find when the boat is due east of fishing boat. So we want x-intercept. This point is what? This point is x-intercept. Is it okay? So at x-intercept, y equals to 0. Okay. Now this equation could be written in parametric form. So I'll say x is 6 minus 6t and y is minus 6 plus 8t, right? Now we want the x-intercept. That means y is 0. So if y is 0, then find t, okay, plus 8t. And solving this, we get 6 equals to 8t or t equals to 6 over 8, correct? Should I write in decimals? Okay, I should, okay. 6 divided by 8 equals to, in decimals, 0.75. So t is 0.75, okay. So we have time t as 0.75. We'll substitute here. So x position or the x-intercept is 6 minus 6 times 0.75. Let's do it. So the position is 6 minus 6 times 0.75 equals to, in decimals, 1.5. Okay, we'll work with decimals. So find when the boat is due east. So this is your position, but time is 0.75. Now this time units are what? Kilometers per hour. So units are hours. And we also found the position also, which is 1.5. Okay. So this point is 1.5. Okay. Time is 0.75. Let's convert to hours. Okay. Now it means 0.75 hours times 60 will give us minutes. Okay. So we'll do 0.75 times 60 equals to 45 minutes. Okay. So we get time. Find when the boat is due east of fishing boat. So it is at this position at t equals to 0.75 hours, which really means 45 minutes. Does make sense to you? Okay, so that's the first part. Okay, so we are trying to solve two different equations. Here is the solution. Okay. Part B. Find the shortest time and position of the boat when it is nearest to the fishing boat. Okay. That means at this point, they will be at right angles. That is the key to answer this question. Now, we know the direction vector for the line, all right? So we know that is the slope m. But what is, let's say this is O, and we'll consider a point P here, which makes the shortest distance. So we can say that point P, so any point P on the line or on the path of the boat, so general point P, what is the equation of that? Well, the equation is right here. X value 6 minus 60, y value is minus 6 plus 8t. Now let the general point be P. In that case, what is OP equals to? I mean the direction OP, okay, OP direction. So that will be, this is 0, 0, right? So the position vector is right there. So this is your OP. X value is 6 minus 60, and y value is minus 6 plus 8t minus 0, 0. So I get the same thing, right? So that is the direction OP. Is it okay? General point. Now, as far as the direction of this boat is concerned, that direction is what? We'll call this as M, right? And M is given to us as minus 3, 4, minus 3, 4, right? Now, if they are perpendicular, in that case, dot product should be 0. So that's the concept. So we are saying that OP dot M equals to 0. That is the concept. So we have this 6 minus 60 minus 6 plus 8t dot of minus 3, 4. That is equal to how much? Let's find this out. So multiplying by minus 3 here, we get minus 18 plus 18t, and with 4 minus 24 and 32t, right, plus 32t. Now that should be equal to 0, correct? So let's simplify this. So what we have here is minus 18 plus 24. So 4 plus 8 is 12, 2, 1, 42, and plus 18 plus 32. So 2 plus this is 10, 1, 50, 50t, correct? So we have 42 equals to 50t. This is equals to 0. So we can find what t is. So it gives us 42 equals to 50t, or t is equals to 42 divided by 50, and that is 8.4, right? Let's calculate. Okay, let's calculate. 0.84 rather, divided by 50 is equals to, in decimals, 0.84, right? So time is 0.84 hours. So after that much time, so it says find the shortest time and the position of the boat. So we found the value of t, so we know shortest time is 0.84 and the position will be, I'll substitute t as 0.84 here and calculate. That's the whole idea, right? So let me do that. I have very limited space, so we got one answer, that is the time. And now let's find out the position. So x value, I'm substituting t as 0.84, okay? So, okay, let me use this blue ink now. So x is equals to 6 minus 6 times 0.84, and that gives us, I'll do 6 minus 6 times 0.84 equals to decimals 0.96, and y value will be minus 6 plus 8 times 0.84. So we have, I'll do 8 times 0.84 and I'll do minus 6, okay, in decimals, 0.72. So that is the position of the boat, right? So we get our answer. So let me write down, this is your answer, right? So let me write down the answer now here, which is after t equals to 0.84 hours, you could convert it in time. That is minimum shortest. Find the shortest time and the position of the boat. I should say find the time and the shortest distance. Find the time and the position of the boat when it is nearest to the fishing boat. Okay, so that makes sense, right? So time is this, and the position xy is actually equals to 0.96, 0.72. That is the position. I hope the steps are clear to you. Whenever the object is stationary, you can use this method. The two paths should be perpendicular. But I'll take few cases when the object is a boat which is moving. In that case, things are different. So look for those videos and try to understand the concept. I'm Anil Kumar, and I hope that helps. You can always share and subscribe my videos. Thank you and all the best.